So we have Unit 2, Lesson 6. So we're solving radical equations using factoring. So in the past I've put this with the radical section, but I really feel like it's better if you actually know the factoring part of it, and this is the factoring section, so I moved it back. So you do need to remember your radical stuff a little bit, so if you're hoping that was completely over, it's not quite. Okay, so we're going to go through first and just investigate some behaviors of radical equations. So we're going to do first. We're just going to kind of check them out. So it says, consider the radical expression square root x. On the grid, sketch the graph of what y equals square root x looks like. Okay, so first off, let's talk about, well, let's just sketch it first. So what values can I put in for x? What values can I put in for x? It can't be negative, right? So we're going to start where? Can we take a square root of 0? Yeah, we can. Square root of 0 is what? 0. Good. Stay with me. So I'm going to put a dot there at 0. Okay, and I'm just going to go with my perfect square because I'm sketching a graph. We don't have to do every single little point, okay? But the next number that's a perfect square is what? 1. We'll just square root of 1. 1. So you guys understand that's a point? 1, 1. If I plug in 1, I get 1. Okay, so what's my next perfect square? 4. Square root of 4 is 2. So we're going to be up here at 2. Okay, and then see 6, 7, 8. Well, we'll say this is 9. That'd be at 3 roughly if we wanted. So your graph is kind of this half parabola kind of growing in that direction. Okay, so based on that information, based on that picture, state the domain of the graph. And this is important, okay, because we've been hearing some bad things in 30 about my math. Some of the math 20s don't remember what domain is. What's domain? Do you guys know? Domain is that it relates to the x, but what does actually domain mean? She said it's with the x. That's correct. It is of the x. If I said, Natalie, find the domain of the function. Yes, it would be x greater than or equal to 0. And what x means, though, by what it's asking where is your graph good for x's. So it starts at 0 and it keeps going to the right. See, there's nothing over here. So we want to write a domain that does not include negatives. Does that make sense? So our domain is everything positive. So you would write this as x greater than or equal to 0. Like she said, that's correct. Okay, you want x greater than or equal to 0. That means all positives, essentially. Okay. Okay, the second question is kind of the same. It says, where is x defined? X is defined in the same ones, all the positive numbers. It's essentially the same question. Okay. All right, so now let's go ahead and look at the second one here. So the second one, a little bit different, x minus 2. So we're going to graph that this time. So this time, if I plug a 0 in, what happens? I get negative 2 and we have a problem, right? So actually, my first point of this graph is going to be where? At 2, because what's 2 minus 2? 0. Do you guys see that? So essentially, it's shifted where? So it was here. Now it's going to be over. 2 spots over. Because at 2, it's 0. Okay, let me give you a second here to kind of digest that. Ask questions if you need to. Okay, I'm telling you, this is a challenging concept. So again, don't make assumptions. Don't say, I'll just keep listening and hope I figure it out. Okay, let's get things going early. So what's happened essentially is what you're going to see is this graph essentially moved 2 to the right. That's all that's happened. Okay. All right, so with that being said, my next point, what is, if I put a 3 in, what's 3 minus 2? 1, square root of 1 is 1. So see, it's just growing the same way. So if I go 3, 4, 5, 6, if I put a 6 in, 6 minus 2 is 4. Absolute value of 4 is 2. So that's our new graph. So this one is just shifted over 2 spots. Does this change our domain? Is our domain different? Yes? No? So if we said our domain was x greater than or equal to 0, is that true? No, our domain now is x greater than or equal to what? 2. Good. This point, right? So x greater than or equal to 2 would be our domain there. Okay. Part 3, again, is a very similar question. It says, for the radical expression, state the restrictions on x. X can't be smaller than 2. So it's the same thing. We can't have anything under 2 because it gives us a negative. This says, solve for the radicand greater than or equal to 0. So what that means is, what's a radicand? We should know this from our first unit. What's a radicand? The inside, right? Radicand's the inside, so it wants us to take this and solve it for greater than or equal to 0. Because what's that mean? Let's read that. Again, I'm going to be very, very thorough today, because this is usually a very difficult unit for my students. Okay? Well, what does this mean? X minus 2 greater than or equal to 0. What's another way of translating that? X minus 2 can't be? Yeah, you're solving, but what I'm saying is this is just saying that this group can't be negative. X minus 2 can't be negative. So all you're going to do is you're going to add 2, just like Math 9, and then you get your domain, essentially. Okay, so we took the inside, set it to greater than or equal to 0, because we do not want negative numbers inside of our radical. Okay, questions yet? Okay. All right, so let's look at the third guy here. Third one's going to be a little bit different. Let's switch to green here. Okay, so consider the radical expression 3 minus 2x. On the grid, sketch the graph for y equals 3 minus 2x. So can I do 0 this time? Like if I plug in 0, here, what's 2 times 0? 0. What's 3 minus 0? Is that allowed? Yeah, I could do that, couldn't I? Root 3? So it's 0 to root 3, so that looks like that's going to be about, I don't know, square root of 3, I think that's like 1.6, but put it like right there. Okay, or no? Yeah, that's right, square root 3. Graph's a little bit off here. Oh, I see it's going by half. Okay, so then, what do you see? I guess, what do you guys see? Did you put in your calculator? What do you see? Which way is it going? It's going to the left? Okay, so it's going to look something like this. Okay, kind of your rough sketch. Okay, it's going to the left. So obviously that's different. It's going to the left. All the ones are going to the right. Jordan, you want to make just a conjecture? You can't be wrong of why it's going to the left? Can you see anything up there that you think maybe is the reason? That's fine. Anybody have a conjecture of why they think? Natalie?
If x is greater than, so you say, okay, 2 times 3 is greater than 3, so it's like 2 times 3 is 6, 3 minus 6 is negative.
Okay, so what she's saying, correct me if I'm wrong, she's saying that since we're minusing an x, as I do bigger positive numbers, as I do, like, see, there's nothing over here, right? If I put a 5 in, what's 2 times 5? Now I'm going 3 minus 10. 3 minus 10 is a problem, right? So the issue is that as I get bigger positive numbers, it gives me a bigger negative number. So it's kind of flipped. Why is it flipped? Because we're minusing an x, okay? We're minusing an x. The other ones, we weren't minusing x. We had x positive. So that's the difference. Okay, so here we go. So let's get here. State the restrictions of the variable in the radical expression. So what's my restrictions? So where do you think this dot is about? Well, let's do it algebraically. Take the radicand, set it greater than or equal to 0. Let's see if you remember your inequality rule. There's only one thing with inequalities you got to remember. Minus 3, negative 2x greater than or equal to negative 3. Okay, so best thing, what do I do now? Okay, and what's that spark? What do you have to do when you divide by a negative with inequalities? Do you forget? You got to flip it. Whenever you divide by a negative, you have to flip the sign. So this is our domain. And let's see if that makes sense. Where does it look like this dot is? What's 3 halves? It's 1.5, right? Look at that. It's at 1.5. And it's going less than this time. That's why it's less than, not greater than like the ones above. Okay, so it's going the opposite direction. So then we can say the same thing here. Any questions with that? Okay. All right. We're good? Okay, here we go. Next round. All right, so radical equation. Radical equation is an equation which contains a radical, a value of a variable which satisfies the equation is called a root. So the root is a value that satisfies the equation. So for example, on those ones, if I set them equal to 0, their roots would have been their domain starting point. So we'll get to this in a second, but that last one will be 3 halves if it was equal to 0, because that's where it's flat. Okay. All right, so let's look to these here. Algebraically determine any restrictions on the values of the variable. So we're just looking at restrictions is all. Okay, so our restrictions come from the what? Where do our restrictions come from? Come on. Close. I'm just asking, like, we always want to look at the radicand, right? They come from the radicand. Because the radicand's in the radical, that's where we have problems. If there's no radical, we can do anything we want. Okay, but we have restrictions right inside here. So what we have to do is what we were just doing, we need to set this greater than or equal to 0. The 8's irrelevant. I don't care about the 8. The 8 can be whatever it wants. My only problem that creates restrictions is negative in the radical. So by doing this, minus 1, divide 4. X greater than or equal to negative 1/4. That would be your restrictions for that equation. Nope, because we did not divide by a negative. Okay, I know there's a negative here, but if this was a negative, then yes. Good question. Okay, second one, 2 minus 5x. We don't care about the negative 7 because it's not in the radicand. Okay, so here we go, minus 2, minus 2. And this one, we would have to flip because we're dividing by a negative 5. So x is less than or equal to 2/5. Will be our restrictions for that one. What are we going to do on C? So when you get done there with B, take a look at C. All right, and think about maybe an idea, or somebody tell me what you think we should do here. Okay, so Andrew, what do you think on C? Like, what do you see as the problem? Yeah, there's 2 different radicals. So do I pick one? Do I do both? What would you think would be more realistic? Good question. No, we can't combine them because they don't have the same radicand. Now, if they're the same radicand, we could do our radical rules. That's a great idea. Okay. Well, there's nothing here that makes one seem more important than the other. Do we agree to that? Right? So we're going to do both of them. We're going to go x minus 2 greater than or equal to 0, x minus 4 greater than or equal to 0. And this is where you have to use your number sense. Okay, you got to use your inequality skills. I'm going to add 2. I'm going to add 4. So I get x greater than or equal to 2, x greater than or equal to 4. Okay, that's your 2 options. But only one works, and I'm going to explain why when you're done writing that down. And then I'm pretty sure it's going to sound like a trick question. Which one works for both? X greater than or equal to 2 or x greater than or equal to 4? Okay, so by works though, I mean does it have values that aren't going to work? So I saw a lot of you say 2, and that I know you're thinking number line, like that one covers everything. But if I pick 3, right, because 3 is bigger than 2, 3 minus 2, we're good. 3 minus 4, we're bad. So we can't use 3. So actually the one we want is x greater than 4 because this one works for both. Maybe that's a better way to say it. X greater than 4 works for both. Okay, it may not cover both, I guess you could say, but that's the one we want. Okay. All right, let me pause it here. I want you guys to take a shot at D and E on your own, and then we'll come back here in a second. Whoops. All right, so looking at D here, a lot of you guys would go with the x plus 2. Remember, we do need to have x positive x by itself. Okay, so first one, I'm going x plus 2. Okay, and right now I just want to make sure we're not solving, guys. Right now we're just looking for restrictions. Okay, so x plus 2 is greater than or equal to 0. 3 minus x greater than or equal to 0. Minus 2, that one's done. X greater than negative 2. So there's my first piece. Second piece, minus 3, that's a positive 3, not negative. Negative x greater than or equal to negative 3, divide by negative 1 to make that a positive x. That means I have to flip the sign. Okay, so we have x greater than or equal to negative 2 and x less than 3. So if we look at that on a number line, what that's telling me is, we'll say we have negative 2 here, we have 3 here. I have solid dot, because they're both equal to, and they're going towards each other. So that's your answer. You actually use both of them this time because they're both in between. Anything between those two works. That's what that's saying. Does that make sense? So one was like, you had to be bigger than 4 for it to work. This one, we want in between the numbers. So you write it, how you write in between? I like to put my x in the middle, and then I go greater than or equal to negative 2, and then I go less than or equal to 3. That's kind of how you write in between with inequalities. Okay, that's an in-between answer. Questions or concerns with that? We're all good? Okay. All right, so then this guy, a little bit different numbers here. So I got 2x minus 7 greater than or equal to 0. I got 24 minus 5x greater than or equal to 0. So at this point, I'm hoping that every time you see a minus x, like a minus 5x or a minus x, you're going to flip the inequality. Okay, you're going to have to flip the inequality at some point because that x needs to be positive. All right, so this one, add 7, divide 2, x is greater than or equal to 7 halves is my first piece. Second piece, minus 24. Negative 5x greater than or equal to minus 24. Divide negative 5. X less than or equal to 24 fifths. Okay, so you understand, how big is 7 halves? What's 7 halves about? How big, decimal-wise? 3.5, right? 7 halves is 3.5. How big is 24 over 5 about? Yeah, 4.8. So this essentially, just so you understand, this thing bigger than 3.5, smaller than 4.8. So is this a between problem or is it a coverage problem? It's between. It's between 3.5 and 4.8. So you'd write it bigger than 7 halves, smaller than 24 over 5. Very good. Awesome. Okay, now we're actually able to move into solving. The first type of solving we'll look at is using your calculator to solve. Okay, that's the first thing we're going to do. So you're going to need your graphing calculators. Everybody have one? Good, good. Okay, if you need one, you can borrow mine. All right, so what we're going to do is you're going to consider the following radical equation. Root x plus 1 equals 4. Okay, so the first thing we're going to do before we get started is we're going to state where is this defined. So real quickly, we're just doing what we just did. We're going to figure out, what x plus 1's restrictions are. Move this down. All right. Okay, so we're just going to do x plus 1 really quickly, greater than or equal to 0. So simply my restrictions are x greater than or equal to negative 1 because I'm minusing 1. Okay, so that's my simple restrictions. Okay, next says explain how to use a graph calculator to solve using the intersect feature. So how you can do this is, intersect is what you're going to do is you're going to make two graphs. Okay, and where they cross, or they intersect, that's where the name comes from, is the answer. So what you're going to do is you're going to take the left side as y1 and the right side as y2 in your calculator. So in y1 your calculator, you're going to put square root x plus 1. In y2 in your calculator, just that next y equals, you're going to put in 4. And that's going to produce a graph that looks like so. So we'll say this guy I'm going to make red. It's going to be just a flat line at 4. Okay, we'll make this one yellow. This one's going to be, starts at -1 and it's going to keep going. Looks like they go at 15, so let's see if I can make a rough sketch here. Okay, it's going to look something like that. So that's what your picture should look like. So adjust your window. Okay, this window, what I would adjust your window to is your x, min, max. Looks like I'd go -3, 20. That's your min, your max. Same thing for your y. I would do -5, 5. Kind of tighten your window down so it looks like the window here in your book. Okay, so to do that, you hit window. Okay, hit window and just go to your min, -3, 2. For -3 is your min, 2 is your max. And then for your y, go -5, 5. Okay, and so we want to find x using intersect feature. Where do they intersect? Okay, so what you're going to do is you're going to hit, I believe it is second trace on your calculator. Second trace. And intersect is number 5. Okay, with intersect, it's actually one of the easier ones to use. It's going to say first curve. All you have to do is make sure it's on one of your lines. Doesn't matter which one, just make sure it's on one of your lines and hit enter. Okay? Then it's going to say second curve. You just got to make sure it's on the other line and hit enter. Okay? And then it's going to say guess. And you're just going to hit enter anywhere close to where they intersect. Okay? All right. And it should zero in. Does anybody have it? What do we get? 15,4 is our answer. So it intersects at x equals 15 because we were looking for the x value. Very good. And we can verify that. Okay. So how we can verify that is we can plug 15 in right here. So what's 15 plus 1? What's the square root of 16? Does 4 equal 4? Yeah, so it's verified as well. So it is true. Okay? Any questions with that? So we just did the quick verification here. I just did E up there. All right, a couple more things here. All right, so move to the next page here. So now we're going to talk about the algebraically solving, so not using your calculator. Okay. So, algebraically, we're going to walk through these steps here. So, in solving, right now, remember, when we're solving, we're trying to attack the x. We're trying to get the x by itself. So, right now, the problem is there's a radical on it. So, we want to think about, well, what's the opposite of a radical? Squaring is. Okay, so we want to square both sides to start. Okay, so that's what we do. And so when we do that, We square both sides. We now get x plus 1 equals 16. And now you can see it's a very simple algebra problem. I'm minusing 1, and then we get the same 15 that we got on the graph. So the key step there was to give a radical, you square both sides. Verify the solution again. To verify, we just plug that back in. So square root of 15 plus 1 equals 4. Square root of 16 equals 4. 4 equals 4. So we are verified. We are good with that. Okay, the next one is where things get a little more difficult. We got to use our factoring skills. Okay, everybody okay with that? Okay, so the next one, if you're getting bored because it's too easy, maybe this will wake you up. Okay, so now we have a 3 plus root x minus 1 equals x. So there's x's on both sides. Okay, so in any type of algebra problem, your first step or your first objective is to what? When you're solving for x, you want to have what? You want to have your x's together. We can't solve where your x's are all over the place. Get your x's together and then solve. So what we're going to do is, I need to get this x out of the radical so I can do something with it. Okay, so I'm going to minus the 3. That's what they did first. Okay, that's what step 1 was. They minus 3. Okay, the next thing is we're going to square, just like we just did. But see what happens on the right, when we square, we have a what? We have a binomial. So we have to FOIL that out. So what's going to happen is I'm going to have x minus 1, and I have to FOIL this out. So I have to do it twice, essentially. X squared minus 3x plus 9. So my right side is now x squared minus 6x plus 9. So let's just assume, or go with, yesterday's lesson was done for a reason. What do you think we want to do here? Yeah, let's get the left side equal to 0, so let's move this stuff over. So now we have 0 equals x squared minus 7x plus 10. Now what would your guess be? Jordan, what do you think we could do with that? It's from yesterday, right?
Sorry, I'm just multiplying.
That's fine. Well, you see a trinomial equal to 0, though, so like, what would you just think we're going to do, like based off our warm-up?
You're trying to find a number that would find like something that x equals that will make the
Left side 0, right? And we're going to use factoring to do that. So what are factors of 10 that add up to 7?
2 and 5.
Good, 2 and 5. X minus 2, x minus 5. Okay? X minus 2, x minus 5. So what are your answers? 2 and 5. Okay? Now, can you have two answers? You could, but we still need to verify them, and this is why the verify step, if you think it's a waste of time, this is where it's not a waste of time. You're going to watch what happens. Let's plug the 2 in. What's 2 minus 1? 1. Okay, so we're plugging it in here. 3 plus square root 1 equals 2. Square root of 1 is 1, right? What's 3 plus 1? Is 4 equal 2? No, that one's rejected. That one does not work out. So our 2 is, red for bad, is not good. Okay, let's try our 5. Plugging the 5 in here. So 3 plus 5 minus 1 equals 5. 5 minus 1 is 4. Square root of 4 is 2. 3 plus 2, 5 equals 5. So this one is good. So x equals 5 is confirmed. Very good. All right, just a little bit of short definitions here, and then we have 2 examples, and I'll be done. Any questions? Okay, so Okay, investigation 2. One of the solutions can be verified, but the other solution cannot be. Can you explain why solving a radical equation by squaring both sides of the equation could lead to invalid solution? Okay, that's because the squaring, it gives us two options, but one option could be in the negatives. Okay, that's where we come from, extraneous solutions, or roots, excuse me. Okay, the processes used in solving investigation 2 lets an answer which is not one of the roots of the original radical equation, or the radical equation in step 1. It is, however, a root of the non-radical equation in step 2 by squaring the original equation. So what happens is when you square a negative, it should equal a positive, but the roots themselves don't equal each other. So the extraneous comes from the idea that right now we're solving, so we're going backwards. So if I solve, like if I told you that for my problem, if we knew the answer was 3, so I square root of 9, I'd get 3, right? But what if it was negative 3? How would that be accounted for? That's the extraneous part. That's the part where you have to check to make sure that it works. Okay, so that's what I'm trying to tell you, is that even though on one of our answers, the first investigation it worked, the second one didn't, because it's the negative answer that it didn't end up being, is the best way to say it. Okay? So in general, the process of squaring may lead to an answer which does not satisfy the original equation. These are called extraneous solutions or extraneous roots. So 2 was an extraneous solution. The one we just did was an extraneous solution. Okay? That's why we need to verify on these, so don't skip that step. All right, so enough of that. These are steps of solving. So always can use that steps. Okay? All right, so example 3 here. So solve the radical equations. Well, this is nice because both sides have radicals. So what would you think would be a nice, easy step that could make things a lot easier? Square both sides, exactly. Square, square. X plus 3 equals 3x minus 5. Now we're just doing algebra. Hopefully here you feel like you're home free. Minus x, add 5. So that's gone. 8 equals 2x. X equals 4. We need to verify. If I plug it in there, 4 plus 3, I get root 7 on the left. The right, 4 times 3 is 12. 12 minus 5 is also root 7. So it is verified. To verify, again, I'm just plugging the 4s into the x's. Okay, next one's a little tricky. Okay, again, we're going to do the same thing. We're going to square both sides. So I get x minus 3 equals 3x minus 5. Again, I'm going to minus the x, I'm going to add the 5. I get 2 equals 2x. Therefore, x equals 1. Okay, with x being 1, we're going to check that. That's a problem. Why is it a problem? I just want to check and it automatically stopped. Yeah, if I put a 1 to the left side, that gives me negative 2. Well, that means that's not possible. So what happens is, when this happens, if your solution can't be verified, there isn't a solution. Okay, that could mean that they're growing at the same rate. That could mean they don't ever cross. Okay, that's where that could come from. Okay. All right, guys, last one here. Last one. Sorry for the long lesson today. All right, solve the following radical equation. So this one I'm actually going to let you guys try it on your own. Okay, so this one's tough because you have that stupid constant. That constant's kind of messing things up. And you can't just square both sides. Okay, if you tried squaring both sides, the problem with that is, and this is a very important concept, because some of you guys messed up on your radicals test of this too. If I said, oh, I'll just square both sides. Okay, when you square that, guys, this isn't square, this isn't square, because you have to FOIL it out. There's a middle there. Okay, because remember, the only thing that cancels is the middle for conjugates. When you square something by itself, you'll have a middle every time. Okay, so you can't do this. So I wrote that up there. Hopefully that doesn't make you do it, but don't do that. Okay, what I need to do is I still want to isolate like I always say isolate a radical, and usually I say isolate the harder one. So the harder one would be the x minus 3. The root x is pretty simple, right? So I'm going to minus root x over. And now we're going to square both sides. So we're going to do this, like that.
Junior class change.
Now with that, this one goes away, so we're happy. X minus 3. This one I still need to FOIL out. I'm FOILing out a 5 minus root x. Okay, just trust your steps. Trust your skills. You can do this. 5 times 5 is 25 for F and FOIL. O, negative 5 root x. I, negative 5 root x. And root x times root x would be a what? Just an x, right? The radical goes away. Anytime you times something by itself with a radical, it goes away. If you want, you're welcome to write x squared, but then that should see that goes away. It's a positive because the negative times a negative. Okay, that simplify would be 25 minus 10 root x plus x. Okay, now we're going to move stuff over to a side. So now, look at this. If I minus this x, I minus x over here, my x's go away. So that's nice. Let's add 3. So I have 0 equals 28 minus 10 root x. I still want to solve for x. So I'm going to go ahead and move this back over here. Makes it positive as well, so we like that. Okay, let me slow down for a second. And then we're going to finish this out. Okay, so what if I'm solving for x? What do I want to do now? What would your next step be? Well, what's the 10 doing to the radical? Yeah, it's multiplying, so I want to divide by 10. So I have root x equals, that simplifies to 14 over 5. Well, how do we get rid of a radical? Square. Now we just square both sides and we're done, guys. So we square, square. So that gives me x equals 196 over 25. That's your answer. Very ugly, but that's okay. You can verify it by plugging it in to the beginning. Okay? You can verify it by plugging it in the beginning and make sure it works. This would definitely be a calculator verification, probably be a little easier for you. So just plug that in for the x's and make sure that it works. Okay, and that's it for today. Long but productive, I thought.